Good morning, ladies and gentlemen, and happy PJ Day. Woo woo. All right, so the video today is going to be the exact same thing we were talking about last week. We're still dividing using area model, but I want to help you understand a little bit better why area model works. So let's look at that. So if we have the number 564 divided by 3, what we're doing when we're using area model is we're using area, we're using space. So this weekend, the Lee County Yellow Jackets, for the first time ever, is going to the state championships, which is super exciting. So let's think about this like a football field. Okay, we know the area on the inside. We know that this is 564. Let's just call it units. Square units because it's area. So we know that this area here is 564 units. And we know that this width is 3. And what we're using with division here is we're trying to figure out what the other side is. Just like if you were doing multiplication area model, we're looking for the inside. For division, we're looking at the outside. So we're truly saying this is the amount of space on the inside, and we're going to split it into 3. Now, when we get to traditional algorithm, you can take this number and straight up divide it by 3. But what we're doing when we pull it apart by place value is we're making it friendlier numbers. And when it's friendlier numbers, it's easier to divide. So I'm going to go ahead and split it up into friendlier numbers. So we know that this is the hundreds, the tens, and the ones. And so we're going to split those up by 3. I'm going to switch markers because I feel like this is kind of hard to see. So I'm going to go through my steps here. So first I'm going to divide. How many groups of 3 can I get out of 5? Now, I'm going to say this until I am blue in the face. If you do not know, list your facts. So we're actually looking at 3s here. So we can go 3, 6, 9, 12, 15, 18. And we can even see here we're already too big, right? So we look and we see, okay, 3 is the biggest we can get. So we can do that once. So we divided. Now we're going to multiply because we want to see how much space is still left in here. So we're going to say 3 times 1, which is 3. And now that we've multiplied, we can subtract. So 5 minus 3 is 2. So we have 200 still left here, and we have to divide that. We still have that space that we talked about in the beginning. So we have to move that 2, bring it on down, and bring it on back. So now we say, okay, how many times can 3 go into 26? So we have some of our multiples listed here, but we're going to need some more. So 18, what is the next multiple after 18? It's going to be 21. After 21 is 24. After 24 is 27. After 27 is 30. You only have to go up to 10 because if you shouldn't have a 2-digit number up here anyway. So you'll be good to go. So we look at our list and we say, okay, 24 is the biggest number we can get without going over. So we say 1, 2, 3, 4, 5, 6, 7, 8. So that means that 3 times 8 is what's going to give us 24. So now we've divided. So now we're going to multiply, looking at our list. So 3 times 8 is 24. And now we can subtract to find that we have 2 tens left over. So that's why we can bring it on down, and 2 tens is 20, and bring it on back, start over. Well, guess what? I just said that 3 times 8 is 24. So I can divide and say 3 times 8 is 24. So I multiplied. Now I subtract, and I have no remainder. So now if we go back to our original conversation here, we can say, okay, in this football field that we're talking about that the Lee County Yellow Jackets are playing on, we know that the area on the inside is 564 square units. We know that this width is 3. And now what we've just figured out is that the length is 188 units. And you could prove that if you wanted to say 188 times 3 is also 564. So I hope this helps a little bit in understanding why area model works, because we're truly talking about the area, the space inside of this rectangle. We're just doing it opposite of multiplication because we know the inside, we're looking for the outside. In multiplication, we know the outside, we're looking for the inside. So hope that's helpful.